50,000 people. That's the capacity of the Colosseum. Now, if you look at it from a structural perspective, it's actually a paradox. We're talking about a massive stone arena designed to hold tens of thousands of people, resting on top of what was historically a swampy, artificial lake. Now, based on the physics of weight and soil, the building should have just subsided into the soft earth. But it didn't. It stands. Today, we're going to uncover the specific mechanical secrets that make this building a precursor to modern stadiums, looking at how the Romans managed to stabilize a mountain of stone on unstable ground. Step into the heart of Rome during the 1st century AD. The structure before us, known then as the Flavian Amphitheater or Amphitheatrum Flavium, completely dominates the urban center. Construction started in 72 AD under Emperor Vespasian, who basically transformed a valley into this giant arena. The scale of the work was incredibly rapid. It was completed in just 8 years, with the final details finished up by Emperor Titus by 80 AD. The facade was this blinding white travertine stone, rising up against the Roman sky. It wasn't just a building. It was a masterpiece of precision, serving as the nucleus for the city's public spectacles. To really get a sense of the sheer mass of this thing, you have to look at the footprint. The Colosseum spans 6 acres, which is roughly equivalent to a professional football field. It measures 189 meters long by 156 meters wide, forming a massive ellipse. The Romans were obsessed with precise proportions. The ratio between these dimensions is 1.21, which approximates the golden ratio. Standing over 50 meters tall, nearly the height of the Statue of Liberty from base to torch, the structure encloses an arena floor measuring 83 meters by 48 meters. This was the stage where everything happened, surrounded by an imposing wall of stone and concrete. Now, this is where the logic of the build really starts to get interesting. We have to address the ground condition. The Colosseum sits on the site of an artificial lake from Nero's time, meaning the soil was originally marshy and unstable. Consequently, a massive stone building would have simply sunk. Roman engineers had to come up with a specialized solution. They engineered a ring-shaped foundation, 12 meters thick. This was an elliptical ring of Roman concrete, poured in layers to stabilize the structure. It functions as a massive donut of stone and ash, measuring roughly 31 meters across in some sections, designed to distribute the weight evenly across the soft earth. Furthermore, the foundation served as a hydraulic masterpiece. Because the Romans intended to stage naval battles, water arrived via aqueducts through underground channels carved directly into the concrete. To prevent the arena from remaining flooded, water drained through a system of 4 channels connected to the city sewer system. This allowed engineers to manage rainfall and make rapid transitions between dry events and naval spectacles. If you look at the exterior, you'll see it's divided into 4 levels, reaching a height of 48.5 meters, comparable to a 15-story building. The first 3 levels blend engineering with a certain aesthetic order. The arches are supported by columns representing the 3 orders of ancient Greek architecture: Tuscan on the ground floor, the Ionic on the second, and the Corinthian on the third. But these columns aren't just for show. They act as structural links between the tiers. The arches themselves are the real mechanical purpose. By using the arch, the builders could transfer the massive weight of the upper galleries downward and outward, guiding the stress directly into that concrete foundation. The 4th level, the attic, is essentially a solid wall with small windows and decorative shields, which effectively contains the weight of the higher seating tiers. Now, let's talk about the longevity of the building. A lot of the survival is due to the composition of its primary material, Roman concrete, or opus cementitium. Unlike modern Portland cement, which relies on a simple hardening process, Roman concrete used volcanic ash, known as pozzolana, mixed with lime. This chemical composition allows the material to react with seawater or moisture over time, actually growing stronger rather than eroding. Recent research indicates that lime clasts, these small pockets of lime trapped in the mixture, serve as a self-healing mechanism. If a crack forms, water seeps in and dissolves the lime, which then recrystallizes to seal the breach. Because of this chemistry, the structure resisted collapse despite centuries of earthquakes and looting that stripped away the travertine exterior. Wait, before we move on, I want to mention that there's a hidden world beneath the arena floor that we'll get into in a moment. Modern engineering often relies on steel reinforcement, which corrodes and causes concrete to spall within decades. In contrast, this building proves that the Romans prioritized chemical stability over brute strength. The entire structure basically acts as a monolithic, self-maintaining machine. Moving from the structure to the logistics of operation, the ground level featured 80 entrances. To prevent 50,000 spectators from descending into chaos, 76 of these entrances were numbered, managing the flow of the general public. 4 grand entrances were positioned at the cardinal points, reserved for the elite. The south entrance served as the direct route for the emperor to reach the pulvinar, or imperial box. The north entrance allowed magistrates to access their seating areas. The east gate, the Porta Triumphalis, was the entrance for victorious gladiators, and the west gate, the Porta Libetanaria, served as the exit for the dead. Inside, the seating reflected a strict social hierarchy. Senators sat in the podium, knights and noblemen occupied the second tier, and the citizens filled the third. Then the slaves and the lowest classes were pushed to the highest wooden tier, furthest from the action. It's essentially the same system we use in modern arenas today. Now we get to that hidden world. About a decade after the inauguration, a 2-story masonry structure called the Hypogeum was constructed beneath the arena floor. This was a complex network of tunnels and chambers housing animals and gladiators and machinery. The arena floor itself was made of wood, covered in sand, harina, to absorb blood. To stage naval battles, the wooden floor and supporting pillars were removed to create a basin. Logistics were managed in the Hypogeum's central corridor, flanked by lateral passages. 28 capstans operated elevators and trapdoors, allowing animals and scenery to appear suddenly on the arena floor. This invisible work ensured the spectacle above remained unpredictable. Above the spectators, the attic level provided the structural support for the velarium, a retractable awning designed to shield the crowd from the Mediterranean sun. To secure this fabric, the Romans installed 240 masts. These were anchored into stone brackets, called corbels, protruding from the attic level. Manipulating this system was a high-precision operation. It required a coordinated crew of sailors to manage the complex network of ropes and pulleys, extending the awning across the arena to manage heat and light. It takes a village, literally, to just move the fabric. Now, there's still a technical debate regarding the geometry of the structure. While often described as a perfect ellipse, careful measurements suggest it's actually an ovoid, constructed from a series of intersecting circular arcs. This polycentric design suggests that the Romans had a sophisticated grasp of geometric construction, allowing them to balance the aesthetic curvature of the amphitheater with the structural requirements of the load-bearing arches. It's a point of study even now, how they achieved such precise mathematical consistency without modern drafting tools. The Colosseum stands as a synthesis of material science and logistical planning. It wasn't just a construction of travertine and concrete, it was an integrated system for controlling mass, water, and human movement. That 12-meter deep concrete ring foundation solved the problem of the unstable swamp. The arch system solved the problem of weight distribution for 50,000 people, and the Hypogeum solved the problem of mechanical staging for complex spectacles. By looking at the 240 masts of the velarium, or the self-healing limeclasts within the walls, we see a design philosophy built on endurance. This structure proved that a building could act as a machine for public life, setting a standard for arena design that persists 2 millennia later. The real question isn't why it survived. The engineering confirms it was built to. But how much more we have yet to discover about the hidden techniques beneath the debris.